This task calls for the development of a function which will return a single integer. So we can set up our function to begin with, and let's call it just get value, and let's pass in a card. Giving a little bit of thought to what data type we should use to represent the card, the Python language offers the string data type but not the character data type. So even if it did offer the character data type, we would have a problem with the number 10 being a double character symbol. So let's go with the idea of using a string to represent a card. Next, we're going to say to ourselves, if we could deal with the 4 letter values first, we might then be able to treat all of the numbers just kind of under one roof. So let's begin by returning the values of jacks, queens, kings, and aces. And I'll just make a start by dealing with aces. So if the card is equal to the ace, then we will simply return the value 1. Otherwise, if the card is equal to, for example, a jack, then we'll return the value 11. And I'll do these in numerical order just to aid the sort of following of the program. I've used elif here because the various options will collectively be mutually exclusive, so it's not going to be the case that it could be more than one of them at the same time. And if I use copy and paste, that should speed up the creation of the program. So we'll put that to a 12, put that to a 13, and just change the symbols then to queen and king respectively. It's making me think about the use of capital letters. Should a card have to be maybe uppercase or lowercase? It would be the standard symbolism that you would use the uppercase letters, but just to make sure, as part of the kind of thinking about the robustness of the program, let's sanitize the input so that if it is given as a lowercase letter, that it's adjusted. So we'll say card becomes equal to card.upper, and that will transform any accidental lower cases into uppercase. Not an essential feature of the program by any stretch of the imagination. Alright, having dealt with the 4 cards that have a face value on them, we now turn our attention to the numbers. So if you were to go by the assumption that the number cards are going to be the only other values that we give, then we could just use else here. And what we could do here is we could return the value of the card but transformed into the int data type. However, this is something of a leap of faith where we're assuming that the card value that has been given is definitely one of the 13 values that we would regard as acceptable. So assuming that the card value is always accurate and is always going to be okay, then that would complete the function, and we could say then that the main body of the program can now be used to test it. We did in here, of course. So let's create some test cases just to make sure that what we've done so far is acceptable and that it is functioning as we would expect. One point is that this is a function call, and if we were to run this, the result of the function would be returned, but then nothing would be done with the result of the function. So we're going to print it for testing purposes so that we can observe what exactly the output was and whether this function is meeting the requirements that we set in the beginning. So let's put in some cards. Let's put in, for example, a 3 just as a single digit number. Let's put in the 10, the one that is a double digit number. Let's put in the ace because it came first, and let's put in a randomly chosen other one. We'll do the queen. Finally, let's do something that's not actually part of the pack. So let's do like an X just to observe how the program behaves, even though I was going by the assumption earlier that this would be, designed for cards that were valid. Let's run it. Okay, so just a quick comparison then of the values. 3 gives 3, yes. 10 gives 10, yes. Ace gives 1, which is correct, and Queen gives 12, which is also correct. However, X is causing it to crash. The error message here in idle is telling us that there's an invalid literal for int with base 10. So let's try to address this then, just in the interests of being a bit more careful and adding a bit more robustness to our function. So let's Okay, where to begin? So we're going to address this part here because this is the part that's causing the problem. The other 4 cases are generally being dealt with acceptably. So when we reach this point in the program here, we know for a fact that we are dealing with, well, we hope for a fact that we're dealing with then just the remaining numbers. So what we could do here is we could try to ask the program to check that the number is in the range 2 to 10. Now, in order to do that, that would mean checking, first of all, if the card is actually numeric. So let's put that in as one of the criteria. If the card dot, then Python offers us the isdigit function to quickly check that it is numeric. Now, something else that we would then need to check would be the range of the numbers. So if the card is a digit, let's proceed with, let's proceed with doing this and then ask ourselves, is that going to be effective? So if the card is a digit, then we can go ahead and just transform it. However, there is always the risk that the numeric value that we provide is going to be out of range. It's going to be out of the range 2 to 10. So I think we're going to need another rule here. So we're going to have to say if the integer value of the card, actually let's work out the integer value of the card and we'll call it numval. Let's say if the numval is that, so if numval is greater than or equal to 2 and numval is less than or equal to 10, then we definitely have a numeric value that is valid, and we can return numval because it is already in integer form and it meets the requirements of the function because it returns an integer as derived here whenever we turn the card into an integer. The thing is that if the card is out of range, then we can report that, let's do a print statement. Let's report that there's an error, card number value out of range, just to give a self-explanatory error message. However, we are in a function, and so we're going to have to return some sort of a value. Let's use -1 to indicate that things did not go to plan. Now, out here we had if the card was actually a digit, so if it's not ace, jack, queen or king, it needs to be entirely made of numbers. So in this case then, it's a slightly different error message, and we're going to say not a valid card, and we're going to also return a -1, and that means that all of our pathways through our function all return an integer value. Okay, let's save that. Let's take a look at our test cases now. We have a 3, we have a 10, we have an ace, a queen. We have this invalid letter. Let's add, for example, the empty string, and let's add a number that's totally out of range. And let's even try maybe like a negative number just to see what happens. Let's try -4. Okay, so when we run this program, and we observe the behavior of the program, let's see if it marries up with what we wanted. The 3, the 10, the ace and the queen are all still given acceptable outputs. Next we have the x. The x is reporting that x is not a valid card, and it's returning -1, which is why that's printing, because line 33 asks it to print the result brought back from the function. The empty string is saying not a valid card and returning a -1. The number 56 is saying error card number value out of range and returning -1. And finally, the -4 is returning not a valid card and -1. So in general, I think we've arrived at a fairly robust solution to this problem. Those added robustness features being somewhat outside of the scope of the task, but nevertheless very achievable within sort of a reasonable time frame when we're sitting trying to develop this function.